Paul Bigg-Wither from Deloitte, not an accountant. But I am here to talk about potholes, so swings and roundabouts. I did spend a lot of time picking pretty pictures of roads for those of you not that interested, so enjoy those. Digital tool to support local councils. It was a really interesting project we've been running for about 18 months now. And if I move on from that pretty picture, I could read out the vision statement and I could spend a lot of time telling you about how we wanted to improve the way that defects are reported and shared and ultimately rectified, and you'll get to see some of that. But I feel like the picture on the right really sums up the situation for most of us who encounter potholes. So the background to this is Transport for New South Wales is trying to holistically think about how networks fit together. You've got trains, ferries, roads, and they're all interconnected to get a good transport. And when you look at roads in particular, there's 180,000 roads in kilometres of road in New South Wales, but 85% of those are the responsibility of the councils. And Transport for New South Wales can't really control how they're maintained, how often they are looked at, and in particular, what is their current condition. So what they aim to do with Asset AI is bring in new technology and enable councils to get a better picture of what is the situation now on the roads and how can we fix them in near real time. And so by providing a platform to councils, we're hoping to enable that situation to improve. So what is Asset AI? It is two main things, I guess, predominantly. It is a sort of software platform, which is what I'm responsible for developing. And then there's a range of technology, different types of sensors that we ingest into that platform and try to make that information more usable. Ultimately, a lot of it is putting cameras on things like road sweepers and bin trucks and things like that. Why are we doing this? Really obvious, to be honest. Improve that efficiency, get that near real-time view of roads. Typically, the way that roads are inspected at the moment is that every 1 to 5 years, they send a LiDAR scan around. Really detailed, but you don't really know what's happening on that road in between. So we're really trying to improve that. The coverage that we're getting with the cameras is sort of typically every 2 weeks, all of the roads in an LGA are covered. So it's a pretty big difference in terms of coverage. We've also spent a lot of time in standardizing the process. It's something boring that I like, but I'm quite passionate about. Some of it's really simple, from calling a crocodile crack or an alligator crack, the same thing, but more about how we remediate those problems and defects and the time that is supposed to take to fix it once it's been detected. And when we bring all of that together, we're hoping to improve safety. I won't lie, when I was told I was running this project, I looked at that, I was pretty scared. There's a lot of moving parts, a lot of opinions. Ultimately, the funding came from the Digital Restart Fund, which we're really grateful for that money to help build this platform. And then the founding partners, Transport for New South Wales, IPWEA, and Canterbury Bankstown Council, they were our main stakeholders. But we also had input from Griffith, Shoalhaven, Wollongong, and a few other councils as well. And then with our technology partners, Vaisala, Retina, who provided the cameras, Compass and Cisco, you'll hear a bit more about that later on. And then the development partners, special call out to Esri Australia, who worked with us seamlessly as a team. It was a really great experience. And I'd like to call that out actually on this project as an example of a lot of organisations coming together for a common goal and really working positively together. It's been an amazing experience from my side. So the technology, the way we've been looking at it is sort of summarised in this chart. So we've got LiDAR down the bottom there. It has the most value, definitely. Most detail, unbelievable information comes out of that. But as I said, low coverage. 1 to 5 years between scans, so not that sort of current in terms of the information being received. The sweet spot in the middle is the cameras that we're using. So high data value, high coverage. The other data set that we're currently using is sort of IoT sensors. In particular, through Compass IoT, we're using the sensors from private vehicles, if you've come across this. So we're getting all the information from bumps in the road, from potentially your vehicles. Definitely not my car. It needs to be sort of post-2018. I don't think a 2012 Forester counts. So modern cars are constantly sending out all of the information about the quality of the road, and so we're getting a live view on how the road is performing. A little bit more on the cameras. They're glorified mobile phones, really. That's all they are. Stripped out, can't make a phone call on them. We use their cameras to do all the work. We currently support 2 vendors, Vaisala and Retina, and there's a few more coming onto the platform over the next year. At the moment, we have 25 live. In fact, maybe 26 today. Port Stephens had their camera installed today. So that makes 9 or 10 councils. I lose count. And they're all driving around constantly. And the important thing is they're fitted to council vehicles. So they're already covering the network. It's passive collection of information. On the non-visual telemetry, so that private vehicle, like I said, it's a smaller pool than you might imagine. At the time, very high coverage in, say, Sydney, but it's going to be an ever-increasing pool of cars as older cars fade out and newer cars are bought. That pool is going to be big. So about 60 manufacturers qualify, about 600,000 trips a day. So we're constantly getting this information about how bumpy a road is. So a little bit more about the data and what we do to it. Process looks simple, it really isn't. We collect all of that information from all of those sensors out in the field, and we bring it onto the Asset AI platform, where we do a lot of work deduplicating. So a lot of these cameras aren't so good at recognizing whether they're seeing the same defect again, because they're driving it at different angles, different times a day. So we do some extra work to process that. We also augment each defect with a whole heap of new information from Transport for New South Wales, from councils, things like road quality, road surface type, speed of road, age of road, surface material. So we get a whole heap of information and we add that to the defect. That then flows into a prioritization scheme as the guidelines from IPWEA. For those of you who understand what IPWEA is, the Institute of Public Works, something in engineering. So they have guidelines for when a defect is a certain size on a certain type of road, how quickly it needs to be rectified. So, on a very fast road, small defect may need to be rectified much quicker than a small defect on a slow road. And we also standardize all of the information from multiple cameras and multiple road systems. And then after that, we push it out and we have a map viewer, which you can see on the bottom there. And we also do some direct integration where we send the information into the back offices of councils as well, so it can be used in their business systems. I always talk about potholes. It's very easy. Everyone knows what potholes are. But these cameras are amazing. They can detect all sorts of things. And I thought it's just important to understand the sort of defects that we are collecting, from graffiti to barriers, guideposts. I think line marking deterioration is the one that always amazes me, how good it is at detecting that. And then I've learnt an awful lot about other types of defects that I didn't know existed. So sweeping is one of those. That's what it is. It looks like it just needs a sweep. And we've got rubbish. Crocodile cracking is my favourite. Ponding water. Rutting, I had to learn what that is. Seems obvious now. And then there's obviously like vegetation management. I think we've got overhanging branches, our favourite potholes. Damage signs they're really important. They're an instant must fix straight away, particularly if they're a hazard warning. And then flushing, which is when you get that smooth surface on a road, which can cause accidents. Mistakes happen. Computer vision's not perfect. I have to say it's been better than I anticipated, unless this is a very large drain. But we built into the platform a way for users to record false positives, so that information then gets pulled back and will go into retraining the models at a later date. So the more we get of that information, the better the models get. So the platform itself, for those who are interested in what goes in the back end, it's built on an Azure cloud platform inside Transport for New South Wales. Predominantly, Databricks is doing the work, most of it anyway, and we use the Delta Lake sort of medallion architecture to manage all of that information. We do use Data Factory to sort of orchestrate everything and is the control framework. And then we do push some information into PostGIS to do some of the more complex spatial work as well. When all the data has been processed, we push that up to an Esri ArcGIS Online platform. And then we make use of the Hub Premium product to enable the sharing of all that information across multiple councils, so they all get their own view on the data. And then we use things like dashboards and Experience Builder to present that information. And we also use Data Factory for that back-end integration as well. Normally I do a demonstration. Last time I did a demonstration, I was promised amazing Wi-Fi. Sure, it wasn't amazing. I'm not putting you through that. I'm not putting myself through that again. It's all very embarrassing and awkward for everyone. So if you do want a demo, come see me afterwards. I've got my laptop with me. I obviously haven't paid my fees to the gods of live demos. Anyway, I do have some screenshots. So when users first log in, they get a dashboard that gives them a real good overview of what's going on just in their area, how many defects by category, the urgent ones, high severity ones, and they can download that information straight from the dashboard. And they're also presented with a range of apps that they can launch, from the map to the Data Explorer. And actually, you get a sneak peek of a POC we ran there. We ran a generative AI piece of work on the platform as well to give users a different way of interacting with the same data. So they could just ask natural language questions of the data. That was really successful, and we're hoping to expand that next year and perhaps integrate it with a map as well. This was textual and charts only, so you could ask a question and return a chart. And it was really interesting. It's a different way of interacting with the data, and the users really appreciated it. On the platform is also a whole heap of documentation and videos. The main interface, we used Experience Builder. It's quite a highly functional Experience Builder interface. We tried to make it as flexible as possible. We have a diverse group of users, from asset planners to maintenance workers, and we wanted to present the information logically, but not limit them on how they could query it. So we built some pre-built queries. We have custom queries. You can select each defect on the map or on the list view. You can do spatial searches. There's a whole range of tools on there to make use of. We also spent a lot of time working with councils to sort of present the information in a more useful way, not just going, here's the attributes. So we do a lot of work where we process the information over time. And a simple example is we track how the defect is progressing in terms of its severity, and we present that the defect is deteriorating. More useful than having to look at numbers and go, it was a 3 and now it's a 5. We try and present that information in a more user-friendly way. The information from those private vehicles that I've been talking about, we present that on a road network. It has its own sort of side panel to control that information. And at the moment, Asset AI is very much focused on sort of the here and now. Its current use case, I guess, is what's going wrong now. And so what we do is we have a rolling 6-week view of the network. And you can see the chart down the bottom. This Trafalgar Street here, something about 3 weeks ago, suffered some event. Maybe a pothole developed, and we can see that there was an uptick in its quality, which means a downgrade in its quality. Doesn't make sense, but that's the way the scale works. We're hoping that the users, when a storm rolls in, after the storm, you may see a steady decline in a certain area in road quality. And that's how we think this data can be most useful, a really live view of how the road is deteriorating. We also track the history of defects over a 6-month window. Again, this is more for the asset planners, not the maintenance team, so they can get a view of how different roads have been impacted by different types of defects over a longer view. So they can see, particular roads really suffering, and that helps make decisions as to whether it's actually more effective to just go and resurface the whole road. And for those of those, we recognize the users who just want the data. So we built just a table view with a lot more filters and a lot more controls just to get hold of the data and analyze the data at really just a table layer. That is integrated to the map, but there's always that person who prefers like an Excel table than a map. So now and into the future, Well, the now is great. We've got lots of councils, and Transport for New South Wales are also using it. So we, like I said, Port Stephens went live today, and so we've got a whole range of councils currently working and using this, and we're taking feedback from them. In fact, we ran some sessions just recently to understand what direction Asset AI should take next, and it's really great, positive feedback. So building more apps. On the same platform, we're hoping to build some natural disaster funding modules. We're probably going to build some more integrations into council systems. So Tech One and Civica are on that list. That was some of the highest rated feedback. Mobile version of the Asset AI, so we can, things the cameras miss can be recorded. And also more machine learning. And I say more because you're getting a sneak peek there on the right of our first machine learning model. So we built one called DSI, which is Defect Susceptibility Index. So what this does is for any road, it predicts how likely it is to develop a defect, one of three. I think it's rutting, potholes, or cracking over the next 6 months. And so that will be a new layer that gets added. And again, that's the sort of thing that helps planning of maintenance to roads. So we're hoping to build some more models on that as well. Thank you. That's it.